I'm okay on most of these questions. I think
Okay.
we'll give it a shot.
Sure.
There may be some that I can't answer, but I
Very
think
good.
for the most part, I'm going to be fine.
Okay.
Um,
Cool. And then yeah, so on this we have to do questions, yeah, 2 through 9, and then 19 through 28, and then 38 through 43.
okay, let's start with 2 through 9.
Cool. Sounds good.
A normal curve is symmetric about what x value?
Um, what does it mean? It's symmetric about what x value?
Well, I think what it means is a normal curve looks like this.
Yeah, like a bell shaped.
Bell-shaped curve. What is it
Mm-hmm.
symmetric about? What x value is it symmetric about?
Um, that's what I'm not sure about. I was really
What's that
confused when
x
he like
value right there? 0.
zero, just zero.
In other words, it is symmetric about the y-axis, right?
Right.
Well, the y-axis is x equals 0.
Okay.
That's how you define the y-axis.
Mm-hmm.
So I got to think that 0 is the only possible answer that it could be.
Yeah, that sounds right.
Okay, number 3. What percent of the area under a normal curve lies within 1 standard deviation, within 2 standard deviations, and within 3 standard deviations?
Okay, so for one deviation, it's 68%.
Okay, how about 2?
Um, no, this is all one question.
I know, yeah.
Yeah,
But
I
2
was putting down
standards
number
is
4.
95%, and what is 3?
Yep, and then 99.7%.
And what that means is the following.
Mm-hmm.
If you know what standard deviations are, is that's going to be the measurement along the x-axis.
Right.
So if I go 1 standard deviation
Mm-hmm.
to the right, let's say that's my standard deviation,
Okay.
then, and I go equidistant to the left,
Mm-hmm.
this amount of area, they're supposed to be symmetrical, would represent 68% of the area under the entire bell curve.
Okay. Yeah, that makes sense.
If I go 2 standard deviations out,
Mm-hmm.
this area represents 95% of the area under the curve.
Okay.
And if I go 3 standard deviations each direction,
Mm-hmm.
now this area is going to be 99.7% of the area under the curve.
Okay.
That's how that works.
That makes sense.
All right.
Okay.
So number 4
Mm-hmm.
has a, now let me work in black here.
Okay. Now, like these questions is what I've been confused on.
Okay. Well, the normal curve, it says it has a mean of 10. So at 10, that's where my peak is.
Okay.
So my curve has to look like this.
Okay.
And they're telling me the standard deviation is 1.
Mm-hmm.
So find the probability that a selected x value is in the interval between 8 and 12. Well, 12 would be 2 standard deviations away.
That makes okay.
So what is the area of the entire curve that is within my dotted line?
68%.
That's 1 standard deviation.
Is that
This is 95%.
Oh, okay.
And that means that the probability is 95% that you'll pick a number between 8 and 12. Only
Okay.
5% of the numbers are going to lie to the left of 8 or to the right of 12.
Okay.
That's how you do these problems. Now,
Okay.
let me just check one thing. I'd hate to be giving you wrong information. Let me look at their definition of standard deviations. I want to make sure that you go in both directions.
Okay.
I can't even. Yes, I can. Okay, here we go.
Okay.
So the mean is the standard deviation. The total area under the curve is 1. 68% of the area lies within 1 standard deviation of the mean.
Okay.
And this is within 2 standard deviations of the mean. Right? Remember, our standard deviation was 1.
Right.
So when I go to 12, I'm going 2 standard deviations away. But I got to go both ways, 2 standard deviations. In order to get 95% of the curve, I've got to go both ways from the mean.
Right. Gotcha.
Even
Okay.
though I haven't really drawn it properly. That's 95% of the total area under the curve.
Okay. This makes a little more sense then.
All right.
Okay.
And then we're just going to do each of these. And they're all the same. So just go to 10.
Yeah.
Let me draw a bell curve again.
Okay. And it's between 7 and 13, which would make it,
How many
let's draw it first.
standard deviations is that?
3.
Yes.
Okay.
Standard deviation is 1. Then I'm going 3 standard deviations right and 3 standard deviations left. So what's the probability that I would pick a number between 7 and 13?
That'd be 68%.
Okay, you gave me the 3 numbers to begin with. 66% is 1 standard deviation. 95%.
That's what I'm missing. Okay.
95, so maybe that's 68 even. 95% is 2 standard deviations. It is.
Okay.
Yeah, it is. Okay. And 99.7 is 3 standard deviations.
Cool. Yeah, so it'd be 99.7%.
Yeah, we're within 3 standard deviations.
Cool. Okay.
Now,
this makes
in science, remember when they were trying to figure out if they had discovered the Higgs boson a year ago? Called the
what?
Most important discovery perhaps in the history of physics.
What was it called?
The Higgs boson.
Oh, okay.
The Higgs particle. They call it the God particle.
Interesting.
It's the particle that gives everything mass. In other words, everything in the universe has a mass. Well, where does the mass come from? It comes from interacting with the Higgs particle or the Higgs field. But that was all just theory. They had never found the Higgs particle, ever, until 2 years ago. And how do they know they found it? Well, you know what they require to prove something in physics? 5 standard deviations.
That's kind of cool.
Which equates to 99.99994. That's the probability that they discovered the Higgs.
Wow.
There's still a very, very tiny bit chance that the particle they discovered wasn't the Higgs. They can never say anything for certain. That's the beauty of probability, is that nothing in the world is for certain. It only is a certain probability.
Is that to like a certain extent, or is that like for everything?
Pretty much for everything.
Because like
You know, when you go out and you get in your
me
car and
saying
you
that like
drive to school, you don't expect to get in an accident. But
no.
it's not 0%. Maybe it's 0.1%, or maybe it's
Mm-hmm.
1%, but
Mm-hmm.
there is a real number, percentage, likelihood of you getting in an accident.
Okay.
When I wake up tomorrow morning, the odds of me having a toothache aren't zero, or
No.
getting a bad tooth, say.
Mm-hmm.
Some percentage. Everything you can think about in life is merely probabilities. Very few
What about like
are certain.
okay.
In other words, mathematically, I can say that 2 plus 2 is 4.
Mm-hmm.
That's a certainty. So there are some
That
math
is
things that are certain.
okay.
When you
Or like what about like I play baseball? Wouldn't that be 100% because I or like
What would be 100% in baseball? Certain,
nothing?
certain.
Is that
Not
throwing
your fielding
balls or strikes?
percentage, not your
Throwing
batting
balls.
average, not your, nothing is 100%. The odds of you
Well,
getting a hit are 50-50 maybe every time you
yeah.
go to the bat. Every
Mm-hmm.
time somebody hits a ground ball to you at shortstop, the odds are maybe you won't make an error 95% of the time,
Mm-hmm.
and you'll make an error 5% of the time.
Okay.
Maybe it's higher than that. But my point is that there's very few things that are certain, 100%.
Okay.
And they didn't need 100% to declare the fact that they had discovered the Higgs boson. They
Mm-hmm.
needed 5 standard deviations. And
Okay.
5 standard deviations means this degree of certainty.
Okay.
So they were
Cool.
pretty dang certain. They just weren't 100% certain. And
Mm-hmm.
they never will be. Even
Mm-hmm.
if they took it to 6 standard deviations, even if you took it to 100 standard deviations,
Mm-hmm.
that's not going to be 100%. It's going to be 99.999999, however far it would go.
Yeah.
I mean, we can tell that 3 standard deviations gives you a 99.7%
Mm-hmm.
certainty.
Mm-hmm.
5 standard deviations is much stronger, but there's nothing that's 100%. Not,
Okay.
in other words, there's always the possibility of an outlier being way out there.
Oh yeah.
In other words, I could have a number that's 1,015,
Mm-hmm.
but it's going to be an outlier. It's certainly not going to come, it's not going to be in the 99.7% area of the curve. It's going to
No.
be in this area over here, the 0.3,
Okay.
because it's an outlier.
Mm-hmm.
In fact, a lot of times they'll throw out the outliers and
Mm-hmm.
work with all the points that do not include outliers.
Mm-hmm.
All right, let's see here. Number 6 is between 8 and 11.
Yeah.
Okay, this is a little harder.
Yeah, it is.
Well, that's 1 standard deviation in that way and 2 in that way. So the
Yeah.
width is 3 standard deviations.
Which is 99.7%. I
No,
think that's
no,
is that right?
because
No.
when we did 3 standard deviations, we were going a total of 6 numbers.
Oh,
We were
gotcha.
going from
Okay.
7 to 13. We're
Right.
only doing half of that now.
No.
Okay,
Okay.
so there's actually a different way to do this. Well, let me do it the proper way.
Mm-hmm.
Let's do it in 2 parts.
Mm-hmm.
First of all, if I draw a line through the mean,
Mm-hmm.
I know that 50% of my curve is this way, 50% is this way.
Uh-huh.
Well, now I'm going 1 standard deviation. What is this percentage of the area of the curve? Just this right here.
That would be
It's not 68%, it's half of 68%.
Yeah, which is 30.
So that
34.
would be 34%.
Okay.
But now when I go this much over here, well, what's this half of?
This will also be half of 68, right?
Half of 95. That's 2 standard deviations to the left. Remember, I'm going from 10 to 8.
Yeah.
Well, standard deviation is only 1.
Mm-hmm.
If I was going from 8 to 12, remember that was 95%. So from 8 to 10 is half of 95%. That's 47.5%.
Uh-huh.
Now I add the 47.5 to the 34, and I get 81.5%.
Okay.
Is the probability that a number will be between 8 and 11.
Okay.
Because it's 47.5% that it'll be between 8 and 10,
Mm-hmm.
and it's 34% that it'll be between 10 and 11. So I add those two areas together to get the area between 8 and 11.
That makes sense. Okay.
All right? And that's the way you have to do them when they're not symmetrical with the mean. This 8 and 11 was not symmetrical about 10.
No.
So I had to do it in 2 parts. And when you do it in 2 parts, just remember everything's in half. In other words, this whole area over there is 1/2. So is this.
Yeah.
The total area under the curve is 1.
Okay.
Okay?
Okay.
So what's the next one?
At most 10.
So they're talking at most 10. They're talking about that entire area, right?
Mm-hmm.
In other words, any number up to 10.
Yeah.
Well, if the whole area under the curve is 1, what's that area?
So it's under 10.
No, don't think about that. The whole area under the curve is 1.
Mm-hmm.
How much of the area under the curve are we looking at?
The entire left side.
Half of it.
Yeah.
Right?
Mm-hmm.
In other words, what I've shaded in black here is half of the total area under the bell curve.
Yeah.
So it's got to be half. So it's 50% probability that you'll pick a number
That's easy.
less than 10.
Okay.
And it's 50% probability you'll pick a number greater than 10.
Mm-hmm.
So any number at all, there's 100% probability you'll pick it.
Mm-hmm.
Okay? At least 12.
Yeah.
Well, let's figure out what area they're talking about when they say at least 12. Well,
So that's talking about the right side.
yeah,
The whole right
exactly. If I put 12 on there, hold on.
Mm-hmm. No, you're good. That's a standard deviation of 2.
Okay. So let's figure out, first of all, what that area is.
Yeah.
It's not 95%. It's half of 95%.
Yeah, which is 50.
47.5%.
Okay.
This area over here is 50.
Mm-hmm.
Well, what's that leave for this tiny area over here?
3.5%.
2.5.
2.5. Thank you.
So the odds of the number being at least 12 is only 2.5%.
Okay.
So when you split it up and you're only going in one direction, you have to take half of these percentages.
Okay.
In other words, if I'm going 2 standard deviations,
Mm-hmm.
if I went 2 standard deviations in both directions, that whole area would be 95%.
Okay.
But that's not what I'm doing. I'm only going to the right to get to 12. So I want to know what that area is. So that's got to be half of 95%. Plus this whole entire area is 50%.
Mm-hmm.
Which only leaves 2.5% available.
Cool. All right.
At most 9.
Mm-hmm.
Well, at most 9 means,
At most 9, so that's their left side.
so we're talking about this
Deviation.
area right here.
Yeah, so that's standard deviation of 1.
Okay,
So
so
you
let's
do
figure out,
half.
yeah, okay, so what is this area right here? That's the area we want.
Yeah, so you do half of 68, which is 34.
Okay, so that's 34. What's it make the area in black?
Which makes the area in black. Wait, so
Remember, the whole area to the left of my mean is 50%.
okay, so 34. Okay,
So
so that would be
minus
16%.
34, 16, exactly.
Yeah,
16% chance that a number we pick will be at most 9.
cool.
Because I know that's half of the,
Mm-hmm.
this is half of 68, so that's 34. So 34 plus 50 is 84. So this everywhere in red is 84% of the area under the curve. That
Mm-hmm.
only leaves 16% over here.
Right.
All right.
Cool.
So that was 2 through 9. We only got 4 minutes. What's the next one?
19. 19 through 28, I believe. And then 19 would be 50%.
Okay. Because it's everything to the right of the mean.
Right.
Okay.
Yeah.
What's 20?
So this would be, does it say standard deviation? No.
See where my cursor's pointed?
I do, yeah.
Okay. What is this area right there? In other words, first of all, I know that 50% of the area under the curve lies to the left of the mean and 50% lies to the right.
Right.
So that's one standard deviation. What's that area right there?
25.
It's half of 68, just like
Oh,
it's
half
in this problem.
34.
34.
Yeah.
Okay. That's
Okay.
34.
Uh-huh.
And there's some area over here. They didn't go all the way to the left. They just went to 3 standard deviations.
Yeah.
Well, 3 standard deviations, what would be the area under the curve from where I'm pointing to the mean? Half of what number?
68. So, or no, half
3
of,
standard deviations is what?
yeah, 99.7.
Okay. So half of that.
Yeah, which is, what is that? 51,
No.
50.5? No.
First of all, if you're taking a number, half of a number less than 100, the answer has got to be less than 50. Because half of 100 is 50, right?
Right.
Half of this has got to be 49.85.
85, okay. Cool.
Now, 49.85 would be all of the area from the mean to 3 standard deviations out there.
Mm-hmm.
Right?
Right.
Well, I got to subtract from that 49.85 this area that I'm pointing at. That's not
Right
part of the area.
Mm-hmm.
In other words, the area from the mean to the 3 standard deviations mark is half of 99.7. So that's 49.85. But we already figured out that that was half of 68, 34. So I've got to subtract 34. What's left over is my area of the shaded region.
Okay.
Number 20. In other words, those 2 bars is 15.85% of the area totally under the curve. So you're always doing these that way. In other words, notice that 22 is even harder because it's just that single bar. You
Yeah,
basically
exactly.
figure out the entire area to the left of the mean.
Mm-hmm.
You subtract off
Mm-hmm.
the rest of them.
Right.
It's a fairly involved process. You can see how we did it on the last problem.
Yep.
That's the way you're going to have to kind of do all of them.
Okay.
21's a little different.
Mm-hmm.
Notice that that's 2 standard deviations away.
Yep.
So if I were wanting the area between this point and that point, it would be 95%,
Mm-hmm.
which leaves how much for the area over there and the area over here? 5%, right?
5%. Yeah.
If the area from here to there is 95%, then
Yeah,
everything
the other
else is
5%.
5%. And that's
Okay.
half of everything else. Only half,
Mm-hmm.
because it's not shaded on the left side.
Right.
So that's 2.5%.
Okay.
And that's the way you're going to do all of these, is you kind of have to figure out the area between, in other words, on 22, I'm going to figure out the area between this point and that point,
Mm-hmm.
95%.
Right.
Then I got to subtract off the area between this point and this point, which is 68%.
Mm-hmm.
It's 95 minus 68, or 27% would be the answer for 22.
Okay.
They always turn into subtraction problems.
Yeah, for
You
sure.
know the entire area out to 3 standard deviations, but you got to subtract off this area that's only 1 standard deviation out.
Okay.
So that's the way you have to do these.
Cool.
Really,
All right.
I got through all those problems without running into one I didn't know how to do.
That's awesome.
Must be
Man,
must be sinking in by osmosis.
it must be. Yeah.
I don't know why I have so much problems with it.
No, it's all right. It's difficult.
Statistics can be hard, but statistics aren't that hard.
Mm-hmm.
Probability can really be hard. You
Oh
can
yeah.
you
Oh
can
yeah.
come up with some probability problems that'll test your smartest mathematicians. I mean,
Oh yeah.
really, really tough ones.
Mm-hmm.
And that's one of the reasons I don't perhaps reach expert level at probability, is because it's hard to get there.
Yeah, it is for sure.
All right, Dylan, I'm going to let you go. I'm done for the day.
Awesome. Get some sleep.
6 hours today.